This is a campus use case. So I'm Vincent Giles, part of the technical marketing engineering team, and these are the agenda for the usual TOI, with starting with an overview, use cases, the details, and especially caveats, and configuration and best practice. I will do a demo on that one. So definition and acronyms that you will find most of them coming from 10.09 TOI on multi-fabric. I added a few, like for instance, what we call a fabric for a set of fully mesh VTEP for the VXLAN data plane, and the border leader. We are going to talk about it as well. So you find all the acronyms in that slide, which is helpful when you read back at your own time the slide presentation. So let's move to what we did in 10.09. So that was a data center focus, one dedicated border per fabric. So in that example, you have 4 fabrics and you have one border that is identified and that used to exchange traffic between fabrics. So that was the data center use case. Unlikely for a campus use case, because having a dedicated border for that one will be unlikely. So for the campus, we come with that particular use case, which is having an aggregation / core collapse aggregation core VSX box that would be identified as the border. So typically that area here that I'm pointing out with my mouse is one building. So building 1, which is one fabric. And the other building, building 2, is let's say fabric 2. So those, the traffic between building 1 and building 2 will go through that VXLAN traffic and through the blue tunnel. So we'll get into that one in detail. And the second use case for campus would be to have actually the border being shared between the fabric. So that would be the second presentation that I'm going to run through today as well. So let's start with that first one, that first use case. So as a first overview, what are needed and where we come from regarding those technology and configuration that is required for supporting this use case. First of all, Next-Hop Self. So the Next-Hop Self for EVPN address family was introduced in 10.09. So that was the new command. Perfect. So this feature was really qualified for a border VTEP in the context of the data center use case with a border per fabric. Very important to remind that, so that the current behavior of that feature is that all the EVPN routes received let's say from an external BGP peer will be reset for the next stops with the Next-Hop Self command for the internal BGP speaker to receive with the border. That's for the EVPN, which is the genesis of this feature. But it also do that for the IBGP route. So typically from a leaf to another leaf inside the same fabric, if you use that Next-Hop Self command on a VTEP, not on a route-reflector, but that is not a VTEP, but on a route-reflector that is a VTEP, this will override the IBGP routes. So that will require some change in the future CX releases that are going to be planned. So the Next-Hop Self command in future should reset the next stop without any further option of that command, only for the external BGP EVPN routes. So, and then later on, we'll introduce a command option to perform the same behavior than today, which is for both EBGP and IBGP EVPN routes. But that's not the initial intent. The initial intent was to have only EBGP EVPN routes. So for the specific case of today, we are going to use an interim solution that is proposed for 10.10 based on route map. In order for that to be a working solution, remember that we have to touch not only the IP address of the VTEP, but as well the router MAC, that is an attribute that you find in the NLRI MP-BGP VPN routes that is used for routing for L3 VNI. So that EVPN router MAC has to be set consequently in the route map. And there is, for that, a new command in 10.10. In the route map, you can now set the extended community for EVPN router MAC. So this is explaining you the how that solution is articulated in 10.10. So typically on the campus border that is a route-reflector, so this is the use case I explained in the topology, we are going to use a route map to mimic the Next-Hop-Self behavior for EBGP routes only. So remember, Next-Hop-Self as of now is resetting EBGP and IBGP routes. So for that, we are going to instead using a route map, and the route map will mimic so that we have the right behavior. So that is to reset the next hop for all EVPN routes coming from the EBGP peer of the fabric, and not touch the next hop for the intra-BGP speakers. So that is what we do here with the sequence 10. Sequence 10 is about matching on anything that is local to the fabric. So the local routes, how we do that, we match on an IS path that is empty. So the regular expression that you see that in the IS path list local-fabric sequence 10 is an empty IS path, which means that we are talking about internal BGP routes that needs to be reflected from that route reflector. Okay, and as a matter for that sequence 10, we do no action. So no action will be just thanks to the permit will permit that that route to be propagated, to be advertised between BGP speakers. And then when there is no match on that one, we continue, so sequence 20. And then what we do, so sequence 20 means that it's a route that is outside of the fabric because it has a non-MTA autonomous number. And that next hop IP and router MAC will be reset and reflected to the route reflector clients. So we will reset with the next hop IP address being the border VTEP, and the extended community EVPN router MAC being as well the border VTEP router MAC. Then you will apply that route map outbound to the route reflector client. So that's not very complex, and this will perform exactly what we are expecting for that to be made. Some quick reminder about type 3 route optimization, as well as this is a new enhancement to avoid unnecessary VXLAN tunnels. So it is not new as such because that was done before in 10.09. I explained that in the TOI. However, there are a bit of tuning that has been made that I'm going to explain. So remind that there is no need to have, so the type 3 routes are the routes that are used for BUM. So any BUM traffic, and this is the route that is used to construct the VXLAN tunnels dynamically between VTEPs. So it's pointless to re-advertise those routes that are inside the fabric to outside of the fabric, right? Because we don't want to have VXLAN tunnels between leaf of fabric 1 to leaf of fabric 2, right? So this was explained in 10.09. Similarly, we don't want to re-advertise what has been received from the external fabric to the intra-fabric VTEP. So there is an automatic filtering process that is triggered for that. Automatically, no CLI to do for that one. This is done by Next-Hop-Self. So the Next-Hop-Self aspect, so there is one which is towards IBGP neighbor, and that is coming with the command that you put on the neighbor, which is Next-Hop-Self command, okay, that you put in the CLI for BGP. And it comes as well for the, I would say, the regular BGP behavior of an external peering. An external peering, you will reset the next hop. So that is a kind of Next-Hop-Self without the command bytes as such, but de facto, regular BGP peering perform a reset of the next hop. So typically here you can see that the route reflector in the drawing here, spine 4, here sends some routes. Here you can see that there is a type 3 route that is with the route distinguisher 2.5, for instance, which is that guy here on the top, bottom left here. Well, that advertisement from outside of this fabric is not there. So we did a good job here in 10.09 to prevent that. You can guess that as we are not using Next-Hop Self, there is a bit of question mark about what will happen to this route type 3 route. So what we did, we trigger as well that same filtering based on the outbound route map that is used to IBGP speakers. And this is what is new in 10.10 as well. So that optimization for type 3 is also done if we check that there is a route map that is applied that has a set IP next hop on it. And in that case, we do the type 3 filtering as well. Right, so this is what is reflected in the drawings here. Instead of Next-Hop Self command that you apply on that route reflector, you apply the route map. And in that case, type 3 filtering is done as well. Good. And just to remind that what are the impact if you are not doing that type 3 optimization, you will have an undesired tunnel being constructed between, let's say, inner leaf VTEP of the fabric. So it could be an access switch, for instance, in campus, to the border VTEP. So this is undesired because you may have duplicate packet. So typically here in my test, you can see the duplicate packet for such a test. So we no longer have such an issue thanks to that filtering that has been set. Good. I hope that this is exhaustive list of what has been exhaustive list and exhaustive sharing of what has been done in terms of code for 10.10. Use cases. So here there is a typically campus use case, and I'm going to drill down into some slides that you already see for in 10.09, because this is really exposing you multi-fabric for campus, right? So we 10.09 was the focus for data center. 10.10, the focus is for campus. So right now you see two buildings, building 1 on the left, building 2 on the right side, and you have access switches. So typically I use a kind of same topology convention, but instead of spine, you'll see that there is a collapse aggregation core box, which is a VS6 here. And that aggregation core collapse is connected to an underlay that could be, let's say, a super core, for instance, of the site or whatsoever. It's an underlay pure L3. All the circuits are layer 3. It could be layer 2 with SVI, but let's do not enter that debate. It's for simplicity, let's consider this is layer 3 only. And what we do want to have is those orange VXLAN tunnels inside the fabric, right, are limited to the fabric. And we have the blue tunnels that are between fabrics to serve as an overlay tunnel for the overlay traffic. And you have another site upstream here as an example. So what we can say for the overlay traffic is that from fabric 1 to fabric 2, you will use an orange tunnel, then a blue tunnel, and then another orange tunnel. That's a maximum of 3 VXLAN tunnels that you have to cross in order to reach your destination in the other fabric. And there will be only one inter-fabric tunnel being used for the overlay. So this is important. There is no, I would say, multi-hopping through multiple blue tunnel. It's direct, only one blue tunnel used between fabric. What happened for the BGP sessions and typically the control plane to exchange those EVPN routes? Nothing really changing inside the fabric. You have those access VTEP that are having a BGP, internal BGP session for EVPN address family to the loopback of the aggregation 1 and aggregation 2, both being route-reflector. So you have pair access VTEP to BGP sessions to those two route-reflector. So this is inside the fabric, and then between the Fabric 1 and Fabric 2 of the same large campus, for instance, you've got EBGP EVPN multi-op session between this VSX primary, and secondary. And obviously, you have one of it that is identified on that site that would be responsible to communicate to the other sites here represented by autonomous number X here. So we have the notion of border leader concept, which is the fact that, as I mentioned, there is only one border that is identified as a border leader to advertise route to the other sites. Okay, so that border in building 2 have no external BGP session to another site, because it would be cumbersome if you have, let's say, I don't know, 6 or 7 buildings in a given site. If you want to exchange to other sites, you would have to have so many peerings to the other sites, so that we identify that notion of a border leader. So think about border leader being really a distributed route server between sites. This is exactly what it is. So let's move on. And so, yes, what I just would like to highlight with these dotted lines here is that these typical sessions here between that non-border leader function, which is just border, does not exist, right? We want to avoid that. So question now that the aggregation 1 and aggregation 2, you know that for some L2 stuff that they are connected, so they are in VSX and so on. What about having IBGP EVPN session between those two for the EVPN address family? Well, that's not something that is useful at all, because what we do care about EBGP EVPN address family is the fact that you are setting the next stop for the overlay. And the underlay is taking care of the reachability of the VXLAN tunnels. So there is no need at all to have a kind of like IPv4 and IPv6 address family, the need to have a same cluster here. Typically for IPv4 address family, you would create a cluster of route-reflector, not for EVPN. For the very important underlay routing, again, very important because this is, you have to make sure that all the loopback address of all those VTEPs are reachable. We do not change anything compared to what we already discussed in 10.09. There is an OSPF process to take an area to take care about internal intra-fabric exchange of loopback addresses. And we do OSPF to BGP redistribution and BGP to OSPF cross redistribution to exchange the route that are learned from outside of the fabric. So we have an external BGP IPv4 session. So this has been already addressed in 10.09. So this is just a reminder. And here there is an internal BGP sessions between aggregation 1 and aggregation 2 as a flexibility. If you need, for instance, to have site X connected to aggregation 1 and site Y connected to aggregation 2, in some scenario, you may want to have the aggregation 1 and 2 being transit for the 1. So in that particular topology, we do not master that. So that could be something useful. To just have a continuity of underlay routing for loopback. Control plane summary, this is everything that I explained for EVPN RS family, plus everything that I explained for the underlay routing. So this is just a summary slide. So let's move on and talk about the next stop objective for the VTEP. So this is, again, just support for the discussion. So this is for, let's say, the other side on the top of the picture here that want to reach, let's say, Fabric 1. So we want to have the routes of the EVPN routes of autonomous number 1 here received on the top VTEP here, that is not shown on the picture, but you imagine it, with the border leader VTEP, that guy here, as the next hop. And you do not want the next hop being the internal VTEP 1, VTEP 2, and VTEP 3. Right? So this is the objective. Similarly, in order for the traffic to go that tunnel, you want the AS number 2, so all the routes in Fabric 2, to be received with the border here, VTEP IP address, and not VTEP 4 and VTEP 5. So pay attention that, by the way, that border does not have EVPN BGP session with the AS with the site on the top. So this is performed by some route map that we have on border leader. So as well, we want the border to reach the site on the top to have all the routes received coming from that VTEP on the top, and not the next hop being the border leader. And similar aspect that I touch here is that it will be done through route map that will be tuning the next hop from the border leader to the border, because the border does not have EBGP session to the other side. Similarly, we want to have the border here, so all the source machines in Fabric 2 to reach the machine in Fabric 1, with the border leader being the next hop, and not VTEP 1, VTEP 2, and VTEP 3. So this is the regular objective for the next hop. In order to achieve that, we have, for the control plane objective that are set, we have to play with Next-Hop Self and Next-Hop-Unchanged. So here, remember, we have the internal Next-Hop Self command that was used in the past in 10.09 from the route-reflector. The route-reflector in the data center is not a VTEP, it's a spine. Here, that route-reflector is a VTEP. So remember what we mentioned. So we'll touch base on that aspect here. And we want to also advertise AS1 routes here with the regular Next-Hop self behavior that you have on external BGP. So this is that arrow here. Same for the same routes going to Fabric 2. Then we want to send the route of the other sides from the border leader in Fabric 1 to the border in Fabric 2. This is what we do that. And in that aspect, we do not want to change the next hop. We want to preserve the next hop so that border 2 will be able to construct a tunnel, to direct tunnel in blue here to the top. And you can see the same similar aspect that AS2 will propagate routes with the natural behavior of external BGP Next-Hop Self, and AOS-CX here will do the same. Similarly, border leader will advertise the route of Fabric 2 to the top side with the Next-Hop-Unchanged. So do not use Next-Hop Self command when the border is route-reflector in 10.10. This is the outcome and the cautious note that I initially share with you. Otherwise, those tunnels here that I put in dark color will not be used, because those EVPN routes will be overridden by the IP of the core layer. So this is why, so this tunnel will not be used, right? It would work, but it would actually not work, because here the data plane would be broken. So what we really need to have is what I explained before, a route map that is used temporarily in at least 10.10, so that we mimic the Next-Hop Self command. So I already explained the route map, so I'm not going to. So I just put it again here so that it's something clear for you. But that's the solution in 10.10. Some details and caveats. So this is supported for V4 and V6. Again, we do not claim support for V6 publicly, but for deployment and proof of concept, there is no issue at all. And there will be a specific TOI on V6 in 10.11. The Border VTEP RouteReflector support for all the platforms. So first of all, you understand there is that new command in the CLI. This is the extended community VPN route map. So that command is available in the control plane for many other platforms. Okay. However, there is a subset that is supported and tested because of the Type-3 selective filter that I explained before. So only the 6400, 8325, and 8360 are qualified for that feature in 10.10. Good. So let's see what is the scale update on that one. You see there is a kind of update that has been made as well for 8325, profiles leaf, VTEP per fabric 128. So this is quite a nice scale upgrade as well. So the number of fabric, the number of routes across all the VREPs, across all sites, the number of overlay MAC and ARP as well with dual stack, right? We systematically, we will validate now IPv4 and IPv6 dual stack. The number of VLAN per fabric, the stretch VLAN among all the fabrics, and the number of VRF that you have here. So you have those numbers here, quite useful, I think, for the border leader. You can see that 8360 is qualified as a border leader in 10.10. It was not the case for 10.9. And for border VTEP, there is less issue here in terms of qualification. So this is the scale. Let's move on with the configuration. I already specified it, but let's just review it one more time. So there is no set action in sequence 10 because for that one, I want to preserve the IBGP routes that are local to the fabric reflected to the RouteReflector client. It will retain the IBGP Next-Hop VTEPs. So this is as if we will not touch the intra IBGP Next-Hop, which is the regular things that we want. And here, sequence 20, the Next-Hop IP and router MAC are reset for the EVPN. You apply that route map, and please, for clarity, suppress the Next-Hop self command that you may initially think to use. So that Next-Hop self command should not be used, must not be used. The target for future release is an homogeneous configuration for campus and DC, and that would be Next-Hop self. So I'm talking about target for the future release, right? So this is just to explain you that this is interim solution, and this is what we want for the future, to simplify. So this is for the overall solution of the campus. This is the route map summary. Okay, so you understand the topology already. We dive into that one. So let's dive into each route map. So you have route map from the RouteReflector back to the intra VTEP of the fabric, and you have route map to outside. And we'll dive into that. So first of all, the route map from the RouteReflector to the client in the fabric. I explained you this already multiple times, so you have it now here. So here, typically, the set IP Next-Hop is the IP address of the border VTEP, which is the loopback that is shared for that. Actually, it's loopback 1 instead of loopback 0 here. This is the shared Anycast loopback used by aggregation 1 and aggregation 2 as the VTEP IP, and the EVPN router MAC that is defined both identical on AG1 and AG2. Let's move on. Similar for Fabric 2, exactly the same similar thing. You see that it's 10.3 here, loopback 1, and EVPN router MAC identical of AG3 and AG4. And that route map is applied to the client. The route map outbound between border leader and the border is similar to what we saw in 10.09. So here, typically, I match on Fabric 4, which is the upstream fabric here. And I'm going to reset the routes coming from Fabric 4 to be advertised between border leader to border with the IP Next-Hop being the Fabric 4, so that I will construct the blue tunnel directly from the Fabric 2 to the Fabric 4. So nothing different to the TY in 10.09. And here, the route map that is from the border leader to the Fabric 4, the external site here, is exactly the mirror of what I just explained, which is matching everything on Fabric 2, so that I will set the next stop when it's Fabric 2 EVPN routes to the IP address of the border that is in Fabric 2. So this is the summary. It's about the same here on that one. When there is no, let's say, there is no over fabric in that site, we just prevent the transit to happen. So it means that this site will not re-advertise to this guy anything that would be learned by another site. Okay, it is explained in 10.09 as well. Best practices: use a VS6 as a VTEP for better availability. Next-Hop Self, you understand that you cannot use it, but theoretically speaking, you can keep it because the route map is overriding the behavior of Next-Hop Self. However, for clarity, really do not use it. So please refer for the troubleshooting to the TOI of 10.09. I'm going to explain a few things here. The check that you have the inside the BGP EVPN AF family, you have the route map properly applied on the route-reflector. Check the route map by itself, so you can do a show route map and to see what is the route map. On the access VTEP, you can obviously check that the next stop IP for EBGP routes are set properly, being the border, okay, and alternatively, you may filter as well with the that command with the particular remote fabric that you would like to check. So on access VTEP, you can also check. This is important, not only the IP, but the router MAC for layer 3 VNI. Let's dive to a quick demonstration. So as you may have seen, I'm reusing a lot what has been done in terms of infrastructure for 10.9. So let's do not dive into so many details. It's pointless, but just to focus on Fabric 1, which is bottom right here, you can see that in that data center demonstration, I had a spine route-reflector. So what I did to mimic the campus use case, I simply moved the route-reflector function out of those spines and put it here, right, on those on that border. So that guy is border. So that would be the let's say the aggregation core of a building, and I put the route-reflector function here. So what I propose to do first is to check that the internal BGP routes are preserved, right? So I can just go to that guy. So I'm on this guy here. Okay, so consider this is an access VTEP, and I'm going to check the loopback here that is unique to that physical switch. Okay, that one is sent to the route-reflector and being actually received back on that guy. So on that one, I'm going to check, and that route is a unique one. I'm going to check that this guy receive it with the correct next stop. The next stop should not be that border, but the next stop should be this 10.5. So I'm going to just check that through the command show BGP for that specific entry. Okay. And you can see that the next stop is 10.5 here and 10.5. Why I have two routes? Because I've got peering with two route-reflectors. Okay, so and you see that none are best because actually the IP address for next stop is the VTEP by itself. That guy shared the same Hanicas, so that's why that example is not really a real case example, but that explains the control plane. So this is good because we preserved the IP address of the next stop. Next is what happened to the other fabric routes. So I'm going to just do a show BGP L2 EVPN path to explain what we see on next stop. So let's take, for instance, this one, which is the second fabric. And you can see here that I've got 10.3. 10.3 is nothing but this border. So I've got all the externals, so I can check as well another one. See, for instance, this autonomous number, which is fabric 4, and that one is 10.3 as well. So the border is the one that is always I would say, the gateway for those. Good. Let's get into another one, which is in terms of check. I mentioned the router MAC. We need to check the router MAC is properly set. So I'm going to take the route that is the first one. Let's say this guy here. Okay, I'm going to check this one, and for that. I'm just doing copy paste in order to speed up a little bit because I think I'm a bit late. Let's take this one. You can see the router MAC is this one, which is 02 and 01 here, which is the router MAC of that guy. Right, so the router MAC has been set properly as well, right? And all of that is done in the configuration. Again, you have to the internal BGP speaker, you have the route map that is applied in the peer group, I suppose. Yes. Here on the neighbor leaf router MAC to route-reflector client. Okay, and I can do a show route map here, and you have the detail, right? So you have the EVPN router MAC and the Next-Hop. Good. So after that, I can do a ping. So this is from that guy to this guy to make sure that L2 VNI is working appropriately. Okay, so I can do so from that guy, which is 12.16, going to ping 12.14 that is there. And the ping is working, right? So I'm crossing all those underlay through that border that is RouteReflector. There are some useful resources that you will find. So the user guide will be updated with such topology regarding VXLAN for as of 10.10. Expect a little bit delay, but that should be in the release for 10.10. And then we have the previous 10.09 update for EVPN VXLAN multi-fabric for the data center that is available on YouTube. That is also very useful for understanding all the concept of border leaders and communication between fabric for the control plane and data plane. With that, thank you very much for your attention.